Okay, so part of the electricity chapter that you have for AS and A levels is that you need to understand how the LDR and thermistor function in a circuit. Primarily, what you're required to remember, at least to solve questions regarding this topic, is simply their behavior with the respective quantity. So this is the symbol for thermistor, and this is the symbol for an LDR. An alternate symbol that you might see is going to look something like this, that a resistor is going to be drawn, and some arrows are going to be represented pointing towards the resistor, which show that this is an LDR. This is what you may see in real life, what an LDR looks like. You're not required to understand this diagram, or at least see this in real life, but if you ever encounter this, you can at least relate to this, that what an LDR looks like and what a thermistor looks like. So what is the behavior that you're supposed to remember? Their resistances with the respective physical quantities are inversely related. So if I were to calculate or if I were to understand the resistance of an LDR with respect to light intensity, then that is inversely proportional to light. Which means that if it's a sunny day, for example, if it's a bright sunny day, then the resistance will be much lower. As you can see that the resistance is on this axis and light intensity is on this axis. And if you were dealing with, let's say, a shade, or let's say under a shadow or a dark, let's say a room, for example, then at that situation, the light intensity is low, so the resistance is higher. So the graph always goes something like this, like an inverse proportionality of mathematics, which is something like this. This is what you have to remember. The other thing that you have to remember is with respect to the thermistor, which exactly has the same behavior with its respective quantity, which is that the resistance of thermistor is actually inversely proportional to heat or temperature or heat energy or thermal energy. So if you increase the temperature, the resistance falls. And if you decrease the temperature or if you cool it down, the resistance increases. Again, an inverse behavior. So the graph actually goes something like this. If this is your, let's say, temperature in degrees centigrade, then this is your resistance. So if you increase the temperature, you can see that the value has reduced from a high value to a low value. So this is what you have to remember. Itni hi baat yaad rakhni hai, which is good enough to solve questions. And the second thing that you need to remember is about series voltage divider rule, which of course we're going to get to that later in the questions. And other part of this chapter, which is not mentioned in the course, but you will find these questions again and again, is the understanding of a rheostat. What is a rheostat? So rheostat is just a coil of wire based on the idea that we have already established, that is resistance is equal to rho L over A. Resistance is equal to rho L over A. So in this we have a coil of wire, right, of a uniform cross-section area of the same material. So material is not discussed, area is not discussed. So what is the conclusion? That resistance is proportional to length. This is the main takeaway of this topic. Now, how the rheostat actually operates. So we have three terminals. We have terminal number 1, we have terminal number 2, we have terminal number 3. I can choose any of the three terminals. So one terminal will be a fixed terminal where we will allow the current, or where we will inject the current to pass through. For example, in this diagram, let's say if this was a diagram, or if this was the case, then this end is still free. So let's say that this end is terminal A, for example. This is where terminal A is connected, where I'm supposed to inject the current after the bulb, for example, for the sake of example, let's say, right? So let's say this is terminal A. So what is going to happen after terminal A? It's my choice. Either I connect this to terminal C, or if I connect this to terminal B. You see, what happens is that if you connect this to terminal B, the current has two choices to go through, right? Either the current enters the rheostat and completes the, let me choose a different color for this. So it completes its path while moving through the coil like this, and then exits the terminal like this. In this case, it behaves like a fixed resistor because the current has to go through the whole length of wire and then exit the other terminal. But what if we want a variable effect from this? What if we want that? So then we would have to choose a movable contact, a contact that can move based on our own understanding. So then I will connect this terminal to terminal number C. Now what happens in this situation? So the current enters, for example, the current enters terminal A, which is associated at this point, which is over here. It enters this point and then starts flowing through this coil like this. It keeps on flowing, keeps on flowing. It could have gone to terminal B as well, but the path isn't complete. You see, terminal B is not connected to the circuit. वो circuit में connected ही नहीं है. तो current के पास वहां जाने का तो कोई रास्ता नहीं. There is no path to go through that. So what happens is that the point of contact where we have the sliding contact, it flows through this box, then through this wire, then through this contact, and then exits the terminal C from this location, right? Now, what if you had moved the contact a bit further? Let's say you move the contact towards this side. Let's say the contact is towards this location today right now, and it is connected at this point. What would be different? So the current, first it had to travel through this much length of wire. Now it has to cover this much length of wire as an extra part. So we've established that if the length increases, the resistance also increases. So what is happening at this point? We are changing the resistance of the rheostat based on changing the point of contact, because when the length changes, the resistance changes, simply purely based on the idea that the current has to travel through a longer piece of wire. That is why the resistance is increasing. That is the only thing that we need to remember about rheostat. Now, once we do that, now we have to go towards the potential divider rule, which we have already covered in AS electricity. It says that if you had two resistors in series, for example, let's say there are two resistors, which is going to be broadly the case in these questions. If you have two resistors and let's say you have applied a voltage between them, let's say 12 volts, right? And one of them has a resistance R and one of them has a resistance 2R. It could be given in the form of a variable R, or could be given in the form of any other value as well. So let's say if this is 10 ohms or 10 kilo ohms, and this is, let's say, 20 kilo ohms or 20 ohms, let's say, then what's the voltage division between them? Now, the simple formula about voltage divider used for series circuit at least is simply whatever voltage you want to measure, जिस resistor की voltage निकालनी है. So you keep that resistor in the numerator, divide this with the total resistance, which is going to be for this whole circuit. So this is going to be 30 kilo ohms as 10 plus 20. Multiply this with the voltage that you want to share between them. जिसने share होना उसको divide कर दें, उसको multiply कर दें इसके साथ. So once you do that, you can very clearly see this is going to be 10 divided by 30 multiplied by 12 becomes 4 volts. इस method का फायदा क्या? What's the benefit of this method? You didn't have to find the current flowing through the circuit by using V equals to IR, and you can directly predict the voltages. इसका ये फायदा है. That's the utility of this formula, or the understanding. And of course, if total voltage is 12, 4 has been taken by this, then the remaining 8 volts will show up over here. That is my prediction, but let's try to solve this as well. So if I had to solve it looking at this perspective, so that would have been 20 kilo ohms divided by 30 kilo. Again, the total resistance remained the same. Multiply by 12. Now, if you do it this way, you will realize that your answer is going to come out as 8 volts. So आप देख सकते हैं, you can see very clearly that we only need to find the voltage of one, we can predict the other one. Or if you started with this, you could have predicted the voltage for the other one, because the total voltage 12 remains the same. So this is the rule, potential divider rule, that we need to remember in our heads, because this is what's going to help us figure out what's going to happen to the voltage and the trends and the currents and everything else, right? Okay, so let's move on to the questions, to question bits. So again, the very first question, he says that the battery is 9 volts. He says that, okay, by the way, this is the symbol for a variable resistor, or a rheostat, if you can say. This is the actual symbol of a rheostat, right? So a resistor with 2 terminals, and the third terminal, which is hanging, which is moving terminal, or the other way around, if it is any sort of variable resistor. Now, variable resistors, what are those? So we have LDR as our variable resistor because it varies. We have thermistor as our variable resistor because its value also varies, and we have a rheostat changing its resistance based on length. This is also a variable resistor. But if you were to universally sum them up in one category, then that is simply variable resistor, or being a variable resistor. So in this case, the resistor value is going to look like this, or the symbol looks like this. So after that, we have 3 choices. We can have an LDR, we can have a thermistor, or we can simply have a rheostat that looks like this. But all of them stem from the category of variable resistance. So over here, in this question, this is given as this arrow format. No need to worry about this. It could have been LDR, it could have been a thermistor, it could have been a rheostat. We don't care. All we care about is what is going to be the voltage between point P and Q. So if we had connected it between P and Q, what would be the answers on the voltmeter? So what can happen? Its value can change from, this resistance can change from 0 kilo ohms to 50 kilo ohms. So we're going to try both extremes. You see, if the resistance of this resistor is 0, then if I apply the voltage divider rule, that would have been simply 0 divided by 10, because that would have been 0 plus 10. And of course, they are in kilo ohms. No need to worry about it, because if we are dealing with kilo in both cases, that will be cancelled out. Multiplied by 9 volts, this is going to give you 0 volts. So we are going to start with a range of 0 answers. So option C and D are not possible. This is not going to be happening, right? So then we move on to the next choice we have. We have the next extreme is it being 50 kilo ohms. Agar ye khud 50 kilo ohms ho jata, to phir kya hota? In that case, if this becomes 50 kilo ohms, then the total resistance would change to 60. Now, if I had to apply the voltage divider rule in this case, it would simply become 50. क्योंकि इसी की voltage निकालनी, this is what the voltage I want to find out across. 50 divided by 60 this time, because now it is going to be 50 plus 10, because it is total resistance, or divided by total resistance, multiplied by the voltage that we are sharing. Now, once you do that, your answer will come out as 7.5 volts, which is going to be option B. That its voltage range is going to vary from 0 to 7.5. It can take up to 0 volts as a bare minimum, or it can take up to 7.5 as a complete maximum, absolute maximum, because some of the voltage has to be lost across 10 kilo ohms as well, because it's in series. In series, voltage divides. Okay, moving on to the next idea. And if you want to see this in real life, this is how it actually is going to go. You see, if this is 0 ohms, for example, and if we close the switch, the current is starting to flow, right? We can see that the electrons are moving, but if I connect the voltmeter across the resistor, the voltage comes out to be 0. Now, if I change its resistance, okay, so let's see the resistance of the other one. The other one has a resistance of 10 ohms. Of course, I've cancelled out the kilo factor because it's the same for everyone. 10 kilo ohms, 50 kilo ohms, it's exactly the same. So calculation pe koi farak nahi padega. Okay, so the other resistance is right now 0. The voltage is 0. Now, what happens if I increase its voltage to 50? Let's remove the voltmeter and let's see what happens with it. But anyways, let's keep it over there. So, अब अगर मैं इसकी resistance 50 तक ले जाऊं, आहिस्ता आहिस्ता तो आप देखेंगे voltage बढ़ना शुरू हो जाएगी. Voltage क्यों बढ़ रही है? Because उसका voltage का share बढ़ता जाएगा. It is going to become more and more involved in the circuit as before. So, क्योंकि वो 10 ohms है, तो हमें इसको 50 ohms तक लेके जाना पड़ेगा. So, let's increase this value to 50 ohms and you will see what's going to happen. 50 ohms हमने कर दी and बैटरी 4 volts की थी. बैटरी को 9 volts का करते हैं तो आप देखेंगे कि हमारा जो काम है वो देखें आपके सामने 7.5 volts आ गए. क्योंकि पहले बैटरी कम की हुई थी इसलिए हमारा आंसर गलत आ रहा था, बट अब हमने क्योंकि बैटरी बढ़ाई है तो हमारा आंसर ठीक आ गया. देखें अब 7.5 इसने लिए तो दूसरे के पास कितने गए होंगे. लेट्स मेजर दैट. तो ये वोल्ट मीटर हमने इसके पैरेलल में लगाया तो आपके सामने 1.5. इन दोनों को ऐड करेंगे दोबारा 9 बन जाएगा. सो वोल्टेज इज डिवाइडिंग बिटवीन द रेजिस्टर्स. ठीक है ना, सही है. ओके, सो वी फिगर्ड आउट दिस क्वेश्चन. अगेन इसके लिए आपको वोल्टेज डिवाइडर रूल जो है वो पता होना चाहिए. उसके बगैर आप ये क्वेश्चन सॉल्व नहीं कर सकते, आपके लिए मुश्किल हो जाएगी विजुलाइज करना. लेट्स मूव ऑन टू द नेक्स्ट पार्ट. So in this part, again, this symbol we remember is for a rheostat, right? हमने तो ये समझ लिया. So what's going to happen in this way? So he says 4 volts की बैटरी है और वो कहता है कि ये दोनों ही 10 है. So this is also 10 ohms and this is also 10 ohms. Now, according to voltage divider rule, if both resistances are equal, then the voltage should be equal as well. So 2 volts are being consumed by this and 2 volts are being consumed by this. But there is a problem. You see, if you move towards y axis or close to y, you're only across or you're only connected across the resistor Q. So उस टाइम पे उसको क्या वोल्टेज दिखानी चाहिए आपको? अगर वो Q पे होता या पॉइंट y पे होता तो y पे उसको आपको वोल्टेज 2 दिखानी चाहिए. ठीक है, तो सबसे पहले तो वो ग्राफ हम देखेंगे जो कि y पे में 2 वोल्ट्स दिखा रहा है. सो दैट इज ओनली ऑप्शन बी. 2 पे y का कोऑर्डिनेट होना चाहिए था, 2 पे y होना चाहिए था, 2 पे y होना चाहिए था, which is not possible. It is only possible in B. B आंसर तो बन गया, but let's discuss this further. So at location y, the voltage is 2. But what's happening when we go to x? You see, if you start moving towards x, if you start moving towards this point, you will ultimately get to this point. ठीक है, तो अब दोनों रेजिस्टर आपके उस सर्किट के अंदर शामिल हो गए हैं, तो पूरी वोल्टेज दोनों रेजिस्टर ही तो ले रहे हैं. 2 वोल्ट ये ले रहा है, 2 वोल्ट ले रहा है. तो अब वोल्ट मीटर क्या वोल्टेज दिखाएगा? तो वोल्टमीटर आपको क्या वोल्टेज दिखाएगा? द वोल्टमीटर इज गोइंग टू शो यू 4 volts because 2 and 2 both are going to be shown equally. इसको अगर ऑब्जर्व करना है तो हम यहाँ पे देख सकते हैं वी हैव अ बैटरी ऑफ 4 volts. दिस इज 10 ohms, दिस इज ऑल्सो 10 ohms. ठीक है, इफ आई हैड कनेक्टेड इट ओवर हियर एंड क्लोज द स्विच, of course it's getting 2 volts, right? But as you start moving closer to the other terminal, which is terminal Y, तो आप देखेंगे यहाँ पे रखेंगे तो आपके पास 4 आंसर आ गया, ठीक है. और अगर आप वहां पे भी रखते हैं वायर के पास तब भी 4 है, क्योंकि वायर की रेजिस्टेंस 0 होती है. इट्स नॉट कंज्यूमिंग एनी वोल्टेज, दैट्स वाई इस नोड पे रखो या उस नोड पे रखो कोई फर्क नहीं पड़ेगा, ठीक है. ओके, सो दिस वुड हैव बीन बी, कि अगर आप एक्स पे के पास आ जाते तो 4 आपका आंसर आता, बिकॉज नाउ योर वोल्ट मीटर इफेक्टिवली इज कनेक्टेड बिटवीन दीज टू टर्मिनल्स. ऑलराइट, और वो दोनों की वोल्टेज बताएगा. क्वेश्चन नंबर 38, थोड़ा सा आप कह सकते हैं कि इट्स लेंथी, इट्स ट्रिकी, बट नो नीड टू वरी अबाउट दिस. बोथ सर्किट्स आर कनेक्टेड इन पैरेलल. हाउ डू आई नो दिस? बिकॉज द करंट हैज टू चॉइसेस. वो इस ब्रांच में भी जा सकता है, इसमें भी जा सकता है. So if both are connected in parallel to each other, then both are getting the same voltage. For example, if this had a circuit of 12 volts, this also has 12 volts, this also has 12 volts, and at this point this will have 0 volt, this will have 0 volt based on the battery terminals. Okay? So what he wants us to do is that he says that इसकी voltage भी बढ़नी चाहिए और ये voltage भी बढ़नी चाहिए. How could I have done that? So ये ऐसे ही हो सकता है अकॉर्डिंग टू पोटेंशियल डिवाइडर रूल, कि अगर किसी एक की रेजिस्टेंस बढ़ जाए दूसरे की कम हो जाए. सो इफ आई एनालाइज दिस ब्रांच, आई वांट द रेजिस्टेंस एंड आई कैन सी दैट दिस इज एन एलडीआर, ठीक है. सो इफ दे आर शेयरिंग द वोल्टेज बिकॉज दे आर कनेक्टेड इन सीरीज, दिस R1 and this LDR are connected in series, they are going to share the voltage, of course, ठीक है. So what I want is to increase the voltage. So most definitely, according to potential divider rule, the resistance of LDR divided by the resistance of LDR plus resistance of R1 multiplied by the battery EMF, which is in this case assumed to be 12, right? तो अगर मैंने इसकी वोल्टेज बढ़ानी है तो इसकी रेजिस्टेंस बढ़ानी पड़ेगी. एंड मुझे मेमोरी से याद है, यही से अब आपको इन्वोक करनी पड़ेगी ना. यू हैव टू इन्वोक द मेमोरी दैट व्हाट डू यू रिमेंबर अबाउट द LDR's behavior. So resistance of LDR is inversely proportional to light. So if you want to increase its resistance because you want higher voltage, because according to potential divider, higher resistance means higher voltage, then you have to decrease the light intensity. So it should be in a low light level or it should be in a dark place. So at least हमारे पास option B or D तो cancel हो गए. It's not possible. Now let's move on to the next idea. अब हमने इसकी voltage बढ़ानी है the other branch, ठीक है. Now I remember that this is the symbol for thermistor, और resistance of thermistor is inversely proportional to heat, ठीक है. Now, according to potential divider, अगर मैं इसकी वोल्टेज बढ़ाना चाहता हूं तो फिर मुझे इसकी वोल्टेज कम करनी पड़ेगी, और इसकी वोल्टेज कम करनी है तो आई नीड टू रिड्यूस इट्स रेजिस्टेंस एज वेल. एंड इफ आई वांट टू रिड्यूस इट्स रेजिस्टेंस, आई नीड टू इंक्रीज इट्स हीट और टेम्परेचर. सो टेम्परेचर क्या होना चाहिए? हाई. सो कॉमन आंसर इसमें क्या बनता है हमारे पास? ऑप्शन सी, ठीक है. ओके, क्वेश्चन 4, अगेन डीलिंग विद द बिहेवियर ऑफ, और ये हमारे पास कौन सी डिवाइस है? दिस इज थर्मिस्टर. वी आर फेमिलियर विद थर्मिस्टर व्हिच इज इनवर्सली प्रोपोर्शनल टू हीट. नाउ इट सेज के लगा हुआ है और ये दोनों सीरीज में हैं तो पोटेंशियल डिवाइडर होगा. दे आर बोथ कनेक्टेड इन सीरीज, सो द पोटेंशियल डिवाइडर रूल विल बी यूज्ड टू डिस्कस देम. इट सेज वेरिएशन विद डिग्री सेंटीग्रेड पोटेंशियल डिफरेंस हुई. सबसे पहले तो डिसाइड करें कि ये ग्रेडियंट नेगेटिव डिक्रीजिंग होना चाहिए या इंक्रीजिंग होना चाहिए. लेट्स मेक अ चॉइस ओवर देयर. लेट्स मेक अ चॉइस. व्हाट शुड इट बी? सो इफ आई इंक्रीज द टेम्परेचर, then the resistance of thermistor decreases. And if its resistance decreases, its voltage consumption also decreases. इसको मैं प्रूफ आपको करके दिखाता हूं. आप बेशक इसी को देख लो, ठीक है. If this circuit is connected, then let's say मैं इसकी वोल्टेज कम कर, इसकी रेजिस्टेंस कम करना शुरू कर दूंगा. If I decrease the resistance, its voltage consumption also decreases, as you can see in the voltmeter as well. मैं दोनों को इकट्ठा कर दे ताकि आप उन दोनों को इकट्ठा फॉलो कर सकें. अगर मैं रेजिस्टेंस कम कर रहा हूं सीरीज कनेक्शन के अंदर तो वोल्टेज कम होती जाएगी और बाकी सारी वोल्टेज वो दूसरा कंज्यूम करता जाएगा, उसका शेयर बढ़ता जाएगा, ठीक है. सो सेम केस इज हैपनिंग ओवर हियर. इफ इट्स रेजिस्टेंस इज डिक्रीजिंग, इट्स वोल्टेज अपीयरिंग ऑन दिस टर्मिनल विल बी डिक्रीजिंग. तो अगर इसकी वोल्टेज कम हो रही है तो बाकी वोल्टेज कहाँ जा रही है? बाकी वोल्टेज के पास जा रही है. तो इसका बिहेवियर कैसा होगा? इट्स बिहेवियर विल बी एक्सपीरियंसिंग एन इंक्रीजिंग वोल्टेज. तो इसका मतलब यह हुआ कि जैसे जैसे मैं टेम्परेचर बढ़ाऊंगा, जहां पे मैंने वोल्ट मीटर लगाया हुआ है जिसके लिए ये ग्राफ बना हुआ है P and Q, it will also show signs of increase. So based on that idea, option A and B are going to get cancelled because I cannot go along with a decreasing trend. So I understand that this is going to be a trend in which theta heat and voltage are actually going to be increasing. or something like this. But now I have to make a choice between a curved graph and you can say a straight line. Now we understand that the behavior of the thermistor with respect to heat is an inversely proportional line. So since this is a non-linear equation, this is a non-linear system, I will expect that the best option out of this will be a non-linear answer. If this had been a straight line, then I could have inclined towards a straight line answer, which is option D. But since we understand that the behavior, this is, यही तो बात है याद रखने वाली कि इनके ट्रेंड्स कैसे, इनके बिहेवियर कैसे, और हमें पता है कि they are actually inverse relationships like this one. ठीक है? So this is what we already remember about them. That is why I will be inclined more towards a non-linear relation as compared to a linear relation, right? So this is how we make this choice. I hope that we understand rheostats. We understand how they work. We understand what the sliding contact actually means. And we understand what thermistor and LDR and how they are actually functioning and how they are used in simple circuits. ठीक है?